Hello and welcome to CS50's Introduction to Game Development Assignment 4, Super Mario Bros. The Key and Lock Update. So for those of you who were waiting for this video to be uploaded or the next assignments to be uploaded, I'm sorry, I know it's a long time ago where I uploaded the previous ones, but I had lots of other stuff to do and now I have time again, and hopefully I can finish this course. Okay, let's get right into it. So the objective for this assignment are read and understand all of the source code, and hopefully we already did this. And the next one would be, which we have to implement our own, program it such that when the player is dropped into the level, they're always done so above solid ground. And yeah, we will look into the code for this. We're in level maker.lua and the function level maker.generate, and we have the for loop here where we generate the level column by column. First we lay out the empty space, and then I added a small section right here where it says if x is less or equal than 3, then we just generate normal simple ground, and this ensures that we always land above solid ground. So the first three columns are always normal ground and no chasms. Yes, that was a really quick one. Let's look at the next objective. Generate a random color key and lock block taken from a sprite sheet, and the key should unlock the block when the player collides with it, triggering the block to disappear. Okay, this one is a bit more complex. We will start by looking on the sprite sheet, keys and locks. Okay, we have 4 different colors for each of them. First row are keys, second row are locks. And first of all, we of course have to import the sprite sheet. This is done in the dependencies.lua, and we import it into gtexter simply by adding a new entry into the table. And also we generate quads for it 16 by 16. Then I added some constants so that we can draw the graphics more easily. I added this keys locks table where we have just 1, 2, 3, 4 for the 4 different colors. And then I added 2 variables which define the offset for a key and a lock. So the offset for a key is 0, lock 4, because it's in the second row of the spreadsheet. Fine. Next, we will look into the level maker. So a quick recap, we are in the for loop where we generate the level column by column, but I added the code for the key and lock below the for loop. So it ends here, and then we have here spawn lock block. Maybe let's look at the key first. Okay, so spawning the key. We have a variable called spawn, false. And then in a loop, we try to find a position where to spawn the key. And basically we just do this by creating a variable with math.random and the width of the level. And then we check whether the tile is like ground and is not a chasm basically. And if this is true, we spawn the key. So first of all, we also look whether there's a pillar or normal ground, and we basically set block height then to the corresponding height, and then we create a key by calling the function getKeyLockBase and passing key ID because we want a key, the height, position, and the color. And I forgot to mention the color is just method random and then the amount of items in the keys logs table, so 4 basically. Okay, so where were we before? Yeah, okay, so get key log base function that I created. So it depends on whether we want a key or a lock. Then the position is different because for a key it's just on the ground and the lock block is like I think 2 tiles above ground. Yes, 2. So similar to the other blocks or jump blocks. And then we return a table with the corresponding parameters. So the texture, position, width and height. Then the key is also collidable, yes. And consumable. This depends on whether it's a key or a lock. So a key is consumable, a lock not. And also only the lock is solid and the key is not solid. And then we also pass the frames, which is just, yeah, in the table, random color, and then the offset, whether it's a lock or a key. Okay. So now we have the key, and then on consume. So when the player consumes the key, we play a pickup sound and we add the object to the player, and therefore we also have to pass the object into the onConsume function, so the key basically. And we also insert, yeah, not in the consume function, but when we spawn the key, we insert it into the objects table and spawn is true. Okay, and for the lock block, it's basically the same. We also search for a correct position. Yeah, where there is no chasm below it, and then we set block height according to the height, where it's a pillar or not. And then we also call this function. This time we pass a lock ID, and I will not cover this function again. We did so already. And here we add also the onCollide function. And onCollide, so only if the player has a key, then we play also a pickup sound and remove the key, and we set also the object dot remove to true. This is also a new variable I introduced in the game objects. And spawn flag is, we cover this later, and then if the player has no key, we just play an empty block sound. And we also insert this into the objects table, spawn is true. And additionally, we remove any block at the key block position because it could be possible that there is already another jump block, but if there is one, we just remove it. Fine, we covered everything here. So as I said before, game objects, I added this remove thing right here, which is which comes from the definition or is false per default. And yes, I think that's it right here. Player.lua is the next thing where we look into. Yeah, okay, so we added here the key object. This is only done in order to display the key when the player collects it. So this is a thing I came up my own because I thought looks really nice. And line 90. Oh yeah, so we have to add the object also in the onConsume function. Before it was just self, and this is also done for the other player states that if an object is consumable, we pass the object into the onConsume function so that in order to have the object in the onCollide, in the onConsume function of the key so that we can pass the object to the player. So yeah, also in the jump state, when we collided on consumer, we passed the object, and also in the falling state. And in the jump state, we also remove the lock block if it's marked as remove. So if we collide with the lock block having the key, the property remove is set to true, and we just iterate over all objects, and if an object.remove is true, we just remove it. So this was also an objective. Okay, play state. Yeah, exactly. So in the play state, we render the key. So if the player picks up the key, we set this key object to the key, and then we just draw it right below the score. So at x5 and y20. I thought this looks pretty cool. Fine, I think we covered everything. I will quickly jump into the game to show you the first two objectives. So the first one is that we always spawn above solid ground. So this is true here. And if we restart the game, this is true here again. And hopefully also for the next one. So yeah, of course it's true. Okay, then let's look for the key. So it should be at a random position. Oh, here it is already. And also the lock is also here. This is quite lucky for us. So if we collect the key, we see it's displayed right below the score here. And then we can open the lock. And now the key disappeared and the lock disappeared. Okay, so the next objective is once the lock has disappeared, trigger a goalpost to spawn at the end of the level. Okay, so goalpost and additionally a flag. Fine, let's jump into the code for this. So first we will look at the sprite sheet of flags. We have 6 different posts in 6 different colors, and then we have also 4 different flag colors right here. And the flag has also an animation between 2 images, basically. Of course, we first add this sheet into gtexters, and also we generate quotes for it. And then I define some constants. So we have flag posts, which are the 6 flag posts. Then we have flags, so these are the indices for the flags with in the quotes table. And then we have also a flag offset, which just is for calculating the color for each flag. So if we have flag 1, if we add 9 to it, we can get to the different post types. So top and middle and bottom, basically. Fine. And as we have an animation, we need to add animation property into the game object, which was not present there. And we also add the update function, which triggers animation.update, and also we render the animation if it's set to true, or not set to true, set to an animation. Fine, let's look into level maker next, where we spawn the flag, and it's spawned when we collide with the key block successfully. So right here, and I define the function for this, which returns us objects table of objects, table of game objects. So now I have it. And we pass tiles objects with height and the color is again defined at the top and is just a random value. Okay, get flag is the next thing that we look at. So get flag, we have a table flag, and there we add the different segments of the flag and of the flag post, of course. So first, again, we check for a valid position. This time we start at the end of the level, so start is with -1. And we just check whether we have a yeah, we have a solid ground, and we also check whether we have no pillar, because we don't want a pillar right here. And if this is true, we store the position. And the Y position initially starts at ground level, basically. Then we of course remove all objects at this X position, so we don't have duplicate objects at one position. And then we create the flag post first. This is done by for loop over the different pole types. So we have 3 pole types: the bottom type, the center type, and the top. And starting at the bottom, so an offset of 2. And we just insert the object returned by generate flag post and pass also the color and the pole type. And this function returns a game object, the correct texture, position, width and height, and more importantly the frame, which is the color, plus pole type times offset. This ensures that we end up at the correct color and also the correct type. It's consumable and collidable, it's not solid, and when we collect it, basically, so on consume, this was my way to implement it. You probably could also implement it with on collide. We play the pickup sound. Oh yeah, this is done later. So we only create the flag for now for this objective. Fine. So yeah, we insert this, and then the for loop goes on while we decrement the height. Therefore, the flag gets taller, basically. If pole type is 1, so if we have the middle part, we insert this middle part 3 times. Therefore, the flag is higher than here, so it's a bit larger. I thought it looks better if it's bigger. And the top is also only inserted once, of course. And at the end, we add the flag with the generate flag function, and also at the corresponding position. To figure this out, I've just tested some offsets, and this one looked best in my opinion. And for the flag, we also have a random color, and we have also an animation between those 2 flag frames. Perfect. And then we return the whole flag table, and we insert every object in this table. And that's basically it for this one. And next, and the final objective, is that if the player touches the post, we regenerate the level, and also the scores should be saved, of course, and the level should be longer than it was before. Okay, for this one we will first look into place. No, do we look? Yeah, I think we can already look at the part which I skipped before. Sorry, generate flag post. Yeah, so the unconsume function. If we consume the flag, basically, the player gets also a score for finishing the level. And I also added a flag segment multiplier, which just means that if the player touches the top of the flag, he gets a greater score than if he just touches the bottom of the flag. And then we just change state into play, and increment the level width, pass the score, and set level complete to true in order to display a message. Okay, so for this to work, we have to add the score to the player, which is defaults to 0 and is can be any score if levels are completed more than once, basically. And if level complete is true, which we set before. If he completes the level, we set it to false after 4 seconds, and for this 4 seconds, this function is executed, so render level complete, where we just display a text, level complete, and then the text disappears again. Okay, so now let's look into the play state. In the play state, we moved level maker.generate into play state enter, so a new level is generated every time we enter the play state. And we also pass some new things to the player. So we pass the score from the previous level, or default 0, and we passed the level complete, which is default false, of course. And then we also, line 88, we render the level complete, which I showed before, if level complete is true. Okay. Yeah, that was it for the last objective. I will quickly show you how it looks in game. Okay. Oh, we're very, very lucky again. So the key and the block are right at the beginning. And yeah, but we will take this. And now we have to get to the end of the level where the flag is spawned. Okay, it should be there soon. Yeah, here we are. Here's the flag, and we have a good looking flag animation. And now we will collect it. Bing, level complete. And we have the score is updated and the new level started. Okay, perfect. So thank you for watching. I hope this video helped you getting done your assignment. Please don't just copy my code and think about the objectives on your own. And it's more fun to be creative yourself and yeah, maybe add some additional tweaks to the game which yeah, make the game look nicer or feel nicer or some other cool things. Okay, have fun programming and bye.